Okay, so I'm starting today's tutorial. So we will be having such tutorials on Python and some of its modules, which will be important for your projects or any kind of work you are doing. So Python is really helpful in um, doing a lot of programming. I think it's better than any other language which I worked with. Like if you take C or C++, Python have more advantages over C and C++, which you will see in a short while. So I will be using this Jupyter notebook to teach this particular tutorial. uh, you will you will get access to this as well. You can install Jupyter notebook very easily in your system and you can just run it. Right, so I am hoping that all of you have some basic knowledge about what programming is. Like I hope that you guys have worked in any programming language before, let's say some C or C++ at any level. The same thing carries over to Python, like variables, functions, everything is same. Only the syntax matters. Syntax varies here, and there are some useful libraries, some useful modules in Python which you can use and which are basic in any kind of scientific work which you do, which we'll be discussing. So first of all, we'll discuss some variables. So just like in your normal C or C++, here variables can be your normal integer type or it can be float type. It could be double or as well, but Python you don't need to specifically declare. Like for example, if you are working in C++, you do something like int c equal to, let's say, 32, something like this. This is what you do in C, C++ or C. But in Python, you don't need to specify the type. So this is called the data type. You don't need to specify the data type. You just need to type c equal to 32 or b not equal to 5. It automatically understands that it is an int data type and it will just store it as an int type. Whereas in C++, suppose if I want to declare a float data type, I type float d is some 32.14. And whereas in the case of Python, I don't need to do this. I just need to type g equal to 9.85 or whatever. It will automatically understand that it's a float. So let's clear this. So here, I hope this expression is familiar to you. This is nothing but ut minus half gt square. So I'm calculating the y displacement. So I'm declaring the variables like this. There are two types of equal to sign. If this equal to is for assigning, this is for assigning the variables, whereas this is to check. This is for checking a condition. This is a condition. Like you will be seeing something like if or if loop, where I can type if a equal to b, then I can do some condition. So this is to check, whereas the one equal to is just for assigning. So there is a difference between both. So now if I just run this, so it will take v naught, p and g, and then calculate this expression. I hope you guys know this. So this, if you just have one star, this is just multiplication. Whereas if you put two stars, it's exponential. So this is t square. So half into g into t square. Okay, and this is how you type comment. So if you want to comment something, you just need to put a hashtag and just comment. Now to print something, you just type print y, or if it was Python, if you're using Python 3, this is the format. Whereas if you're using Python 2, you just need to type print y. But we will stick with Python 3. So if I do this, you will see that there is a syntax error because this is only valid in Python 2. So to check in which language you're working, which version of Python you're using, you can just see here. It's Python 3 of this particular Jupyter notebook. Okay. So here, if you want to create a new notebook, you can come here and you can choose whether to create a notebook with Python 2 or Python 3. It's your wish. But we'll work in Python 3 only. And so this is the basics of variable declaration and printing stuff. Then we'll come to importing libraries and modules. So here I'm working with a module called math. So math module is present in almost any programming language. In C++, it's there. Math, you can import it in your C++ code using hash include in that case, math.h. So if you're working in C++, you do something like hash include math.h, something like this. Similar to this expression in Python, to import something, you use the keyword import and the particular library, which is in this case is math. You can specify a keyword as m, which means whenever I use m dot sign, which means it is going to that particular module and finding out the function. So here it is m dot sign m dot pi. Or if I don't want to do this, I can actually import the whole module, import math. I'm sorry, import. If I just do import math, then see, this will give you an error to print v. Oh, okay, I already imported m. That's why it's giving. So if I am starting the program again, this will give me an error because it doesn't know what m is. In that case, I need to type math as a whole. So math dot sign math dot pi. Okay, but instead of typing the whole word math out, I can just use a keyword m and then use m instead of math everywhere. Right now here, suppose in here I just want to use sign in my code. I don't want to. So whenever I do import math as m, it's actually importing the whole library as a whole. But what if I just want to use a specific function? So this will import all the import the whole module or library. But what if I just want particular functions? For that, I can just say from math import, let's say sign. Okay, so this will just import sign from math. So I can just type here, let's say. Now, if I don't use the m dot reference variable, reference thing, it will still work because I have already imported sign here, right? Now, if I just comment this line out, see, it's working. But if I want to do pi, let's say, okay, pi is not defined. So how do you define pi? I can just take pi again. So I can just specify pi. I can import both sine and pi from the math library and then do this. So yeah, it's working. So instead of importing the whole library, I can just import few of its functions and then work with it. And I hope you know what this output represents. So this e minus 16 refers to the exponential, and this is the this is your what is this? Is this Mandisa or yeah? I think this is Mandisa. Yeah, and this is the exponent. So this is this number times 10 power minus 16. That's how you. Yeah. So you were supposed to get zero. Sine pi is zero actually, but you are getting a very small number because of there's always a precision error associated with any function you do because the computer is working numerically, so you don't get the exact zero. You get the exact zero only when you give the value zero. Otherwise, you will only get number which is close to zero. Okay. So this is the basics of Python variables and modules. It's very similar to any other programming language which you have worked with. Coming to the next important feature of Python or any programming language is the looping functions or the ways to loop over a code. Um, So I'm interested in doing this calculation. We know that sin x Maclaurin series is this, and I want to write this series. Let's say so. Sin x. See, here I use the way I imported the sine library, right? I imported the sine function from the math library, right? But you should ask, like, what exactly is that library? What exactly is that function? What does it? How does it calculate sine of pi or sine of pi by 2? So it calculates using such series because computer doesn't know what a sin x is. It all it knows is basically variables, multiplying, dividing, addition, all those kind of basic arithmetic operations and handling variables. That's all it knows. So I need to convert the complex functions and complex nonlinear equations into something very simple. So here I want to find sin x. So sin x, I already know it exists. There is a Taylor series expansion for sin x. I just used that. I hope you know this series expansion. And the problem here is that this is an infinite series. It never ends. So, but I have to end it because I cannot waste the whole computing power and just keep on adding new and new terms. So I need to end my series somewhere, and for that I use the truncation. So here I am truncating, let's say till 7. So after 7, whatever is the extra term, that is my error. That is why I'm getting sin pi as some other answer, because there is a truncation error associated with it. And how do you find the truncation error? Yeah, so this is the truncation error in this case, because v minus 0, because 0 is my absolute value, right? So the value which I computed minus the actual value is your error, which is this, which is very minute. Order of 10 power minus 16 is something which you can neglect. It's very close to 0. So yeah, so there is a truncation error associated with it. Here it's order of power 9. So let's see how to calculate this. So first of all, I need it to be looping, because every time I have a value, I add some other value to it. So this is something which you loop it. So I'll just write it. I need to use a loop to find sin of x. Just 1 second. Okay. So I need to loop to find sin x. So I should first of all take x value. So this is my algorithm. First of all, whenever you are given with a task to write a program, it's always good to write your algorithm. So you need to take x and then compute. So first you will compute, let's say, compute x. This is the first variable here, x, and then it should compute x cubed by 3 factorial. Okay, and so you can notice a pattern here. So the pattern is that it's all odd numbers. So if I start with, let's say, n equal to 0, um, sorry, n equal to 1. So if, let's say, if I assign n equal to 1, okay, so once this loop is executed, then I can write n equals n plus 2. So after this loop is executed 1 times and it computes x, then your value of n becomes 1 plus 2, which is 3. Then the third part of the method is, so once I found x, so n is 3 in this case. So I need to now find x cube, right? So I can find x cube, and I have to divide by 3 factorial. And for factorial, either you can write a function by your own, or you can directly import the factorial thing from math. So I'll just do that. I'll just import the whole library this time. Okay. So this time you get this. So you can notice every time you just need to find x power n by n factorial. That's all. Where n is always n plus 2. If it is 3, the next time it becomes 5, and next time it becomes 7. Till you can end it. So the ending condition. or the truncation, right? And that's how you do this. That's my algorithm. Now let us implement this. First of all, you take some value which I want to find. So here I'm finding sine of 1.2. X is 1.2. Now I need to truncate it to some order. I am putting n equal to 25 for my truncation. We'll see what is k, what is sine and all. Yeah, I don't need to import math again. Uh, okay, let's import math again. You don't need to do this, but so here I'm using my loops. So suppose if I run this, you expect a lot of errors here. I'll explain all these errors and stuff. So this is a loop. I hope you know what's a while loop. So while loop will execute till the condition is evaluated to be false. So I'll execute this loop till k is less than 25. K is 1. So every time you increment k, once k crosses 25, this loop is not executed. And here, this is my error here, expected and intended blocks. This is something very unique to Python. Python expects you to intend your code. What do you mean by intending? So whenever you are encountered with a colon sign like this, you are supposed to have the code with a tab. So you should tab it, which means that, so in C++, if you remember, I'll write the code in C or C++ in while loop code. So you write something like while k less than n. Okay, you put this parenthesis, right? And then you write your conditions, your statement. This is the C++ or C equivalent of while loop. Whereas in this case, here instead of specifying the parenthesis, I have to do this intent, which means it belongs to one particular block. So all these codes belongs to the while loop. That's why I need to put a tab so that they all fall under the while loop condition. Okay, I'll explain each term. Just here in this. Okay. So the first term, sine equal to minus sign. So my sign is I declare my sign to be 1.0. Every time sign is minus sign, it becomes minus 1. So the first time when I run the loop, sign will become minus 1. The next time when I run again, minus 1 into minus 1. Sorry, minus of minus 1 will become 1. So it alternate between my 1 and minus 1, just the kind of thing which I want for my algorithm. So that is being sorted out. The first term is x, which I already wrote here. S is equal to x. So I don't need to worry about the first term. Now I need to worry about the second term, which is x cubed by 3 factorial. I already have k equal to 1. So I need to assign k equal to k plus 2. Now the first time k will become 3. And then it's just matter of writing the term, which is sine, which is minus 1 in the first case, times x power 3 divided by the factorial 3, which is 3 factorial, math dot factorial. And then you just need to add to the previous term, which was s, which is x here. So x minus x cubed by 3 factorial. Once the loop is done, again it will go back and see the condition is true. It will come here. Sine will become minus of minus 1, which is plus. Now k was 3 already. Now it is 3 plus 2, 5. So sine will become plus 1. X power 5 by 5 factorial. You're adding it back to the previous term, which is s. So the s, once the loop is done, s will be your answer. Now I just want to print it. Okay. So for the printing, you can use this. So here, this is just your normal printing, but I am formatting it a bit. I'm using this thing called %g, or I can use anything. So there are various terms. You can put %f. F stands for float. So if I put f, let's see what will happen. So this is x, s, and n. So it will take these values, whatever are present in this, and then print over here. Okay. Sorry. So you can see sine of 1.2, which is the first thing. and percentage G. The next one is 0.932039 with 25 terms. So if I, let's say, change this to F, which is for the float thing, it prints the float, whereas D is for integers. Right? Similarly, if I can change in this case, it will print F, or if I print D, it will just print 0 because it's a very small number. So yeah, that's how you did. That's how you format your print so that it looks really nice. So we did this code for finding the value of sine of 1.2, which is truncated to n equal to 25. I hope you understood how to use while loop. I'll just pause for a minute and see if you have any doubts. If you have any doubts, just let me know. If you, if you have no doubts, we can proceed. You can just tell in the chat. Can I proceed? Okay, I take that as a no. Okay, fine. Right. So I'll proceed further. Okay, next is creating a list. So list is a really important data type. It's just like your arrays in your C or C++. Again, you will encounter arrays in a minute, but in the general form, an expression something like this will create a list of all the numbers which you declare in the list. Actually, it need not be just numbers; it could be any data type. Like I can put, so this will create a list of C. So if you see C of 0 will be your first element, which is -10. C of -1 will be your last element, which is 30. So you can also do something like this. You can do C2, C0 to 2. Okay, this will print the first two elements, -10 and -1. So this will go from 0, print, will print from 0 to n minus 1. So here it is 0 is -10 and 2 minus 1, which is 1. C1 is -5. I do, let's say, 0 to 9, no, sorry, 0 to 8. So it will print till then. Also, it can actually emit the 0, still it will work. Let's see what will happen if I do this. C of colon -1. So in this case, it will go from the back. So so this is just C of -1 is just the last number. This is just the last number. Whereas if I do C -1, this will go from the last. Also, I can do this. So in this case, if from the second last element, it goes back. Yeah, so from here it will go till 5. So it's 0, 1, 2, 3. Sorry, from here it will count 0, 1, 2, 3, 4, 5. So that's your fifth element. So I'm sorry, I messed it up. Sorry, 0, 1, 2, 3, 4, 5. Yeah, it is this. So this is your C5, which is printed here. It will it will start from the last element, second last element, because it's always n minus 1, and it will go to 5. That's some basic array list manipulation. And as I said, you can also write, characters inside the list, like I. Also, you can put numbers, right? Then if I do C of 3, so this is just a number, whereas this one is a character, right? Now you can do many things with C actually. C dot append, which actually add a new element to the list. So if I print C again, you can see 0 will be added to the end of the list. Um, Actually, there are a lot of functions. So to see what are the functions available, you can just type tab. So you just need to type the list dot whatever operation which I'm gonna do. If you don't know, You can just type tab and see all the kind of functions which are available. For example, let's work this particular thing, sort out. So if you don't know what is this particular function, sorry, you can ask for help. So this particular function sort will no, sorry, not like this. Help sort. Okay, there's no detailed description, but this will just sort the array. So yeah, you can. There are a lot of functions. You can access them all. If you don't remember the name, you can just type tab and see which is the particular function which you want. And this particular operation will add 40 and 50 to the list. It won't do the arithmetic operation. It will just add to the final two elements. So the 40 and 50 is added. Now, if I want to write a for loop, so if I'm doing a for loop, let's say in C or C++, there you do something like this. So if I want to print the whole array, you do something like for, there'll be a initialization condition like int I equal to 0, int I equal to 0, then there will be some condition where you can stop. Let's say you go from 0, 1, 2, 3, 4, 5, 6. So I want to go till 6, and I do this incrementing I plus plus operation, and then I'll just print def in that case, whatever. So in this case, it's C of I. This is what you do in C, C++. It's very easy in Python. You don't need to do initialization at all. So instead of that, if you take a variable, let's say small c, and then type like for small c in capital C, print list element. So this will iterate C and initialize C to each and every element once the loop is done. So for the first run of the loop, C will be high, and for the second loop run it will be hello. So if I just run this, so error is there. Percentage d is not a string format. I need it to be string because it is string. So again you'll okay. So we run into an error because this is a mixture of both string and integers. You can do one thing. You can write a if condition and say that, let's say, so this is how you do. So if we check for a condition, so if you want to see a type of a particular variable, so z of 0 is high. If you want to find the type of this guy, you just need to see type of z of 0 str, right? So I just need to see if type of C, okay, equal to str, right? In that case, I'll just print the thing. Okay, it requires format mapping. I'll do one thing. I'll print only for D. Int. Okay. Mm. Okay, in any case, whenever you are stuck with something, let's say this is a kind of error which I have not encountered before, so you can always do a search. So this is my error, format request mapping. Just search for it, you'll always find something in Stack Overflow. Let's just sort out this. So this particular process is called debugging. So this is an error. I want to debug this error. So let's read this. Okay. Okay. Ah, why did I put this bracket? Mm, a number is required. Okay, let's see if I put str. Oh shit. Okay, got it. I'm just typing the type here. I need to type C. Uh, Again, number is required, not str. Oh, so yeah, this is how you find your errors. So my error was I was writing two brackets. I was including this inside the bracket, but I should have just used my bracket here. Okay. So again, I made an percentage deformatted numbers. Where am I making an error? If you find the error, just let me know. Speak through the mic. Um, so the error is here, but percentage. Okay, let's just print C and C. Yeah, so this is working. So if the type is str, it's just printing hi and hello. Whereas it was, so there is something wrong with the formatting, which we'll sort it out later. So if I type in
Pranav, I think percentage D only takes in like numbers or something. I'm not too sure. Maybe.
percentage d will take integers, I guess. So yeah,
Yeah.
that's
So I think you should change it to something that takes in a string.
oh, I was using string. Oh, still a number is required, not a type. Uh,
Instead of percentage
oh,
D,
okay.
try.
Yeah. Okay, it's my mistake. Yeah, now we got it. What is this HITR? Okay, I need to write in brackets, I guess.
Try only percentage S.
Yeah, that will work. Yeah, good job. Yeah, so I was just making the stupid mistake. So yeah, this is how you debug your code. You need to always work out where the where is it missing and then make it. Yeah, so if I was using integer here, int, then it's just percentage d or f. What? Oh, it's integer, so it should be d. Then yeah, this will work. So yeah, that's how we sort it out. Okay. So I hope this is clear. So this is how we manipulate lists in Python. Okay, then we'll move to functions. Um, so before that, you should know what's a built-in built-in Python function, built-in variable, and sort of stuff. So if you see these things lit up in green, like print some, this means that these are all keywords. Okay, so I cannot do something like, let's say, print equal to 3. This is an invalid assignment because this is a keyword. I cannot write my variable name as a keyword. So yeah, you shouldn't do that. Instead, you have to always use. So yeah, in Python you can actually do this. So you can rebind the name sum to an int. So so sum is a keyword. So here, if I run this, sorry, so Python 2. That's why you don't need braces, brackets. See what will happen. Okay, I forgot intention. Okay, I'll come to this function declaration later. I'll just run this code first. Right. So first thing you can see int object is not callable, which means it's an error because sum is something which is a keyword. So let's just use something like yes. Two images. Okay. Just 500. Oh, okay. So okay, let's just jump into the function declaration for now. So to declare a function, you first write def. This is the keyword definition. This is the function definition. Function definition, and you take in this arguments. So these are called arguments, whatever you write inside the bracket, and then you perform some statements. So here I am just writing s equal to n plus 1. So this is what I wanted to show, that this particular s which I'm using inside the function is a local variable. If I write s equal to 500 outside, then it's a global variable. But this particular s has only its scope inside the functions scope. It doesn't have a global scope. Whereas this is again your function. So when I write s is equal to, so this is how you write a function. So you use def, which is the keyword for writing function definition. Write the function name, then the arguments, then this colon, and then the statement. Finally, you have to return something, or if you are not returning anything, just return 0. So here I'm returning s. So whenever I run the function, my function, with some argument, it will return the value s which I calculated. Yeah. So here, there's a function to find the displacement, which we did before. Again, indentation. Okay, so I declared it. Now I'll just call the function. So to call the function, you first write the function name, yfunc, and then declare some pass. So this is called passing the arguments. Passing some arguments, let's say some initial time, let, let's say some time 10 seconds and some initial velocity of 0. Oh yeah, this is the displacement, right? So it returns this particular value. Okay. So I'm just printing some for some values. No matter. Just check this. So okay, see, I am returning just the position here, but I have declared both position and velocity to be returned. So for that, I'll go over here. I don't know why I'm declaring. Oh, this is the final velocity, right? So here I'll find the final velocity, which is, let's say, v final. Uh, what's the final velocity? V naught minus d into d. Um, let's run this again. So this time, if you run this, I have to return that again. I forgot. So here I am returning two variables. One is the final velocity and the displacement. I get a list basically of two uh, things, because one is the final velocity and another one's the displacement. So now if you see this, you will get, oh, uh, what is this error I'm getting? Okay, just leave this error. We'll see it later. So every time I'll declare. So when I get this two kind of variables, I can always unpack them like this. So let's say this is bf comma disp equals to this. So then if I print vf, that will be minus 9. Okay? If I print disp, that is this. So this is how we unpack the final values. Okay, this is how you write a function and call it. So now let's see an example of whatever we have learned so far. We'll do a numerical integration using this Simpsons rule. So there are a lot of numerical methods to carry out integration. One such method is Simpsons rule, where you approximate your integral into summations like this. A and B are your initial values. Sorry, A and B are your values where you want to integrate your function, and N is your number of steps, your step size which you want to pass, and H is the interval between the steps. So you can define H as like B minus A by N. That is your H. And yeah, first of all, you need to write a function definition. I already written here. So my algorithm will be every time I run the function, sorry, every time I run a loop, I need to run one loop to calculate this particular value and another loop for this value. So this particular f is the function which I want to integrate. So I have to pass a function to another function. I can do this easily in Python. I just need to pass the function name. So f is my function's name, and a and b are the two a and b's here. And the number of step here I have assigned by default to be 500. So first it will calculate h equal to b minus a by n. So sum 1 equal to 0. This is my first sum. And then I do a for loop for I in range. So range is a function which takes the values from that initial value to the final value minus 1. So this will go from 1 to n by 2. So I will go from 1 to n by 2. And then sum 1 will keep on adding sum 1 equal to sum 1 plus f of a plus 2i minus 1 times h. Similarly, sum 2 will be sum 2. Oh, okay, I think I should mention this. This is equivalent to writing sum 1 equal to sum 1 plus whatever. Instead of writing sum 1 twice, you can just write plus equal to instead of doing this again and again. Um, so that's how you format it. And then finally, you just need to bring them all together. B minus a by 3n times fa plus fb plus 4 times sum 1 plus 2 times sum 2, and finally just need to return the integral. Okay, but there are some errors in this code. Can you guys spot the errors? There are some errors. Okay, I'll just run and see what are the errors. Okay, you won't see any errors initially because it's just a function definition. I'm not running it. Only when I evaluate it, you will find the errors. So let's evaluate for a function. Let's integrate 3 by 2 sine cube x. Where did I write dx? Let's just integrate 3 by 2 sine cube x. So to do this, first of all, I'll declare, I'll define a function 3 by 2 sine cube x, which is this. Then, so I have to do Simpson rule. First of all, I need to pass the function's name. This is the function's name, which is h. So I'm doing it for different step size n. And then a is 0, b is pi, m dot pi, and n varies from 2, 6, 12, 100, and 500. So this will give me the values. So there is the actual integral value is 2. So 2 minus approx will give me the error of the code. Now if you run this, It's getting some errors like int object is not callable. I think we are getting the same error before. I should have checked. So this means that why am I getting this? Because if you see, the range will only accept int values. How to spot the error? So if you uh, why am I getting error there? Just remove this. Okay. So the error is here in the function. Inside the function, the error is over here. This particular line 7, which is this line for I in range 1. So if you look over here, n by 2, n is a integer. When I divide it by 2, it becomes a float value. So that's my problem. I need to convert this into an integer because range will only work for integers. So there you go. I'll do that. Syntax. Again, I'm getting this error. I'll just find out why am I getting this. Okay, I did some binding. That's the problem. That was because I was working with the sum. There I messed it up. I'll do one thing. I'll whenever you encounter such a problem, you just need to stop the kernel. I stop the kernel. Okay. Then I can just restart the kernel. It's running. Where? Okay, we were here. Now let's run and see. Now you see it's working. So yeah, that was some error which we did previously, which was interrupting us. That's why I stopped the kernel and did it again. So here you can see for each n values, I'm getting my value, which is the value I. So you can see this 18.15. This is again a formatting method. When I do this determines the number of precision I want. Like when I type 0.15, which means I'm keeping 15 things after the decimal point, 15 numbers digits after the decimal point. So you can always define your position for the floating point and then write. This is the exponential. This will give me in terms of exponential. Yeah, and that's how you format the output. I hope you understood the way we did the Simpsons rule. Okay. So yeah, any doubts till this point? Have some doubts again. Okay, you guys were saying. So please let use the mic and let me know whenever you have some problem, because I can't read the chat always. Okay, so I think we can proceed if you guys have no doubts. Okay. Uh, this is something. So you know that in C and C++, when you were working with, you used to do you used to take input from the user, right? You can do the same thing in Python. This particular keyword will help input. So when I do this, it will ask me for C. Input 10, let's say. Then if you see, the value of C is 10. So that's how you do, but it will always input as a string. If you check the type of C, it's a string, but I can always do a type conversion from string to integer and it will give me the integer. Okay. And to open any file, let's say something like data1.txt, I can use infile. Infile is this. So in C++, you had something like F stream where you did the kind of data handling. Here, input output operations. Here you do the same thing. You open followed by the text, the file's name in any mode. So here I'm using read mode. That's why I put R, and then I can read it. And then in file dot read lines will read all the lines, and I can do it. You can do it by yourself. I don't have a file name data one right now, so it will show this error. Make sure you have the file in the same directory as your work. This is my directory. I'll just open a text file. I'll create a text file called data1.txt, and then I can type something like hi, hello there, blah blah blah. Okay, and then if you just save it, then it will work because it's in the same directory. Otherwise, you need to specify the path for the particular file. Okay, and oh, I closed it. There is nothing being taken. I don't know. Okay, that's it. And to close it, you just to type in file whatever you have mentioned here. Dot close. Right. Now I'll just discuss a bit about NumPy. You'll see that NumPy is really useful. So NumPy's website is here. This is where you can start. First of all, you need to install NumPy library. For that, you can use pip install. Uh, I think where is it? Where is the installation? Oh, there. Yeah, to install you can either install SciPy or NumPy. Okay. So to install you can use something called as a pip. Uh, in the case of Linux, uh, or and the case of Windows also you can install, or you can use something like Anaconda where you have already all these libraries installed. Yeah, but the most popular way is using pip. Just write Python pip install whatever is your library. So first of all, you need to install NumPy. Once NumPy is installed, you can just import NumPy. Import NumPy as np. So you're done importing, just like how you imported math. Now let's see some features of NumPy. So there's something called as NumPy array. Yeah, I put tab. Yeah, so you don't need math if you're using NumPy, because NumPy already has all those math features like NumPy dot sin x, NumPy dot all the mathematical operations like absolute value of something. You'll find everything in NumPy. NumPy dot square root. Sorry, NumPy dot square root. Right. Okay. So you'll find everything in all the mathematical operations in NumPy. The most important type of thing in NumPy is related to the NumPy array, which you will declare something like this. So let's say array one to np dot array followed by the array which I want. Unlike your list, this is not a list. This is different. So if you check the type for this guy, type array one, see it's called numpy dot nd array. You can always specify what kind of variable you are taking by typing this. So this is float. It will print everything as float. Now if I see array 1 0, you'll get a float. Whereas I can also take it as int. Like this will give me int. Okay, this is how we work with NumPy arrays. You can do everything you do with list in NumPy. The same things which you whatever you do in a list thing. There are additional features in NumPy. Like there is something called as np.arrange. Yeah, this is how you go to help. Just need to type np.arrange followed by question mark. So you can see the thing. So arrange, start, stop. If you want, you can put step. So you will go from one thing. So you can see np.arrange 3 will just print 0, 1, 2. 3 to 7. So this is start and followed by a stop. So 3, 4, 5, 6. 3, 7, 2. It will go in steps of 2. So 3 and 5. We'll just try that out. np.arrange 0, comma 10 in steps of, let's say, 0.5. Okay, so this is extremely useful. Let's say whenever you are plotting something and you want to arrange your x-axis, then you can see this is my initial value in the x-axis, the final value, and this is my step size. That's how we do. There's another interesting thing called np.linspace. So np.linspace will be something like, so between 2 and 3 I can take as much values. Between an initial value and final value, it will sample as much as I want. So let's say between 0 and 100 I need 1000 points. This will give me 1000 array worth of 1000 points like this. Okay. Also I can work with two-dimensional arrays, which you can declare like 2D array equals np.array. So your 2D array will look something like this because I want to. It's an array of arrays. That's how you put it. So something like 1, comma 2, 3, comma 4. I shouldn't put 2. So now if you can see how to access that. So if I do np.array 0, it will print me the first array 0, 1, 1, comma 2. If I want the first element in the array, I'll use 0, 0. Okay. This is how you handle matrices. Suppose I want to declare an identity matrix of size 3 cross 3 cross 3. So you can do something like 0, 0, 0, 0, 1. Sorry, 1, 0, 0, 0, 0, 1, and then 0, 0, 1. Okay, 0, 1, 0. Okay. If you see D array, it will look like an identity matrix. Um, yeah, and you can do all sort of matrices, linear algebra with this, and you can also, there's something called as np.zeros. Let's find out what is that. So np.zeros will create an array of size, whatever size you are giving, with filled with zeros, like np.zeros of 5 will be something 0 np. So if I do something like np.zeros, comma 3, comma 3, this is my size. So this will give me a 3 cross 3 matrix with filled with zero. So this is my zero matrix. And there is another interesting features like np dot empty. So this will give me an array filled with some garbage random values of thing, but it will give me an array of that particular size. Yeah. These are the some of the tools for NumPy. Again, to have a proper view of all the tools in NumPy, you can go to this particular website, NumPy's tutorial. You will learn all about array slicing, array shape manipulation, copying, then some linear algebra. Let's look at this. For example, you can do a transpose of a matrix, like you can print it, and then you can do a dot transpose, like this is my matrix A. You can do a dot transpose, It'll give me the transpose, which is basically the same thing. Let's do the transpose of D array, which will also give me the same thing, which is because it's an identity matrix. Also, you can there is I think determinant function. No? Oh, I think that is np dot det. Np dot determinant. Okay, there is nothing like that. There will be some value which you have to find out. I think it's just np dot det. No. So if you are stuck in such cases, you can always refer to the documentation and see what are the particular function that gives you the value. You can always search it. You can just always do a Google search as well, like NumPy determinant function will give you. Yeah, so there is. Um, no, this is not the documentation. Yeah, so the documentation says that it's under the lean alg thing. Let me just try that. Yeah, it works. Yeah, because it's a zero matrix. If I do it for D array, I should get 1. So yeah, you can also do something, lot of linear algebra tricks using NumPy. This is just the surface level of NumPy. NumPy can do a lot of things, like it's like the basic for all kind of scientific manipulations and stuff. I'll also introduce you another library called random. Random is for generating random numbers. So random.random will give you a random number. Okay. So this will generate me a list of some random numbers. You can put this thing called seed. So whenever I put seed, it refers to regeneration of the number. So if I do this 2 times, okay, I get 2 different values, right? But if I run the seed again, then I can get back my previous random numbers if I use the seed thing again. If I do it again, see, I'll get another thing. If I do it again, we'll get something else. But if I come back and put seed, since I use seed, in that case, I should be getting that back again. So if I run it, I come back to this. So seed is to regenerate given output. Random numbers are also useful in data analysis. We'll come to that in future sessions. Um, I think this is enough for the first tutorial. We discussed a lot about arrays, a lot about NumPy. I hope you can go back and read more about the NumPy in the NumPy documentation. Just go to NumPy user guide, just read some stuffs like NumPy basics or quick start tutorials. Yeah, just read some. Yeah, this is also important. Input and output using NumPy. You can use NumPy to get data from any text file. There is something called as load text, which will help you load stuff from a text file. So yeah, these are the basic stuffs about NumPy. Tomorrow we'll discuss another important library called Matplotlib, which is for plotting. We'll also see some the same library has a function for animation. We'll see that as well, because some of the projects require some form of visualization. There is a superior library for NumPy which is called SciPy. You can install that also. SciPy. SciPy is again used for, so NumPy and Matplotlib is under SciPy. Again, Pandas is another useful stuff. You can always install and um, learn about it. SciPy will have a lot of stuff regarding various scientific methods, like let's say if you want to do Fourier transform or something, you will find libraries for that. So go to SciPy. So, for example, we were doing Simpsons rule for integration, right? So there is already a SciPy library where you can do the integral. Where is it? Integration, yeah. If you go to SciPy.integrate, you will have all the methods. So Sims is the method where you do Simpsons rule to compute the integral, right? So yeah, that's it. That's how you do. That's how you just need to import it from SciPy.integrate, import sims, and then carry out the integration. So instead of writing the code, writing my algorithm, every time I just need to import SciPy and then use SciPy.integration and find it out. So yeah, this is the basics for Python.